And soon we will be, exactly. So we're also launching some people's books on this channel who are members of this channel. And gosh, your present address. Do you want my address? Oh gosh. Well, I am in the USA. Yes. I probably shouldn't be any more specific than that, given the situation here. Eversource says I'm so ready. Okay. We're gonna get started. Okay. So we're also launching some people's books here on this channel. Steven is one of them. Steven is a member. So if you become a member of this channel or if you come to the live streams a lot and you contribute positively, then chances are if you wrote a book or if you have a science fiction novel or a science novel or a science paper that you want to share with us on the channel, we are happy to launch it here, okay? So Steven actually sent me a part of his book, which I'll be reading soon. I'll do a reading of that probably Sunday or Monday, okay? So with that, I'll get started with tonight's author. Oh my gosh. This is Professor Dr. Mr. Lawrence Krauss's Atom, okay? We begin when what is now the entire visible universe of over 400 billion galaxies, each containing over 400 billion stars, each 1 million times more massive than the Earth, encompassed a volume about the size of a baseball. Gosh, the simplicity of this statement belies its outrageousness. It is impossible to intuitively appreciate this era by making the leap from here to there in one giant step. But it is possible to imagine a series of smaller steps, each of which itself pushes the limits of visualization, but each of which gets us closer to fathoming the truly extreme environments we're about to enter. So he's going to talk about some very extreme things now going forwards, okay? So hopefully you're ready for that. Our first step begins with our own sun. So by the way, I should mention that our own sun is quite young, quite far from dying, and it is constantly burning for us and turning hydrogen into helium, and that's how we get light, energy, heat, and all that good stuff from the sun, okay? Let's see what he has to say. But sometimes when stars are much more massive than our sun and closer to their death, they can die and turn into these more compact objects, namely white dwarf, neutron star, or black hole. So those are the three options when you die and you're a star, okay? Let's see now what Dr. Krauss has to say. Our sun is far from its death at the current moment. It's actually gone around the galactic center of our own galaxy, of course, the Milky Way galaxy. It has gone around our galactic center only about I believe it was like 21 times only. So in that sense, it is barely more than a teenager in the sense of this galaxy, okay? So our first step begins with our own sun, almost 1 million times as massive as the Earth. So indeed, the sun is much bigger than our Earth. Now, I don't know if we should even really compare our Earth with the sun. The sun is a star. By the by, hello Jeep, hello Stephen. By the by, we all come from a gigantic gas nebula, quite metal rich, which condensated to make the sun and its planets, in other words, this solar system of which we're a part. And a little bit above 99% of the mass of this gigantic gas nebula actually went to our sun. So of course we are much smaller than the sun, the Earth, the planets are much smaller. And guess what? Most of the mass went to the sun, but most of the angular momentum went to the planet. So that's why we all rotate on our axes. Well, some of us don't rotate very much or rotate very slowly, but we also, the Earth is spinning on its axis, it's going around the sun, blah blah. That's because we carry a lot of this angular momentum from the gas nebula, but we don't carry most of the mass from the gas nebula. That is the sun that carries that. And of course the sun is a star. We cannot really compare a planet to its star, right? The sun is its own thing. The sun has a nuclear power plant in its belly, and it's constantly doing nuclear power, turning hydrogen into helium. So it's doing nuclear reactions. That's how it stays burning.